All right, so as we move on with the unit circle, the big thing that we're going to do on this lesson is we're going to use this unit circle and we're going to get away from thinking in degrees and we're going to move to radians. So what you'll find is, unless we're doing application problems, so real world problems, we are going to do everything in radians in this class. So what's important is that we can do everything in radians without converting to degrees. So you have to get out of your mind, this is a radian is how many degrees. So we're going to talk about this, and then this is something that I'm going to give you a couple of strategies for this. So if we think about where we are in a normal circle, so this first one that we're going to do here is degrees. So if you remember, this is my initial side of my graph. So this is my initial side of my angle, and we're going to say that we're going to start this unit circle, right? Unit circle, so we're going to go in a circle at 0 degrees. And as we go all the way around this, if we go all the way around, then we end at the same point and we've gone 360 degrees. So if you think about this, if we go halfway and we see that this is a right angle, we've gone 90 degrees. And if we go another half, or half of 360, we've gone 180 degrees. And then if I go another 90 degrees, down here I end up at 270 degrees. So these are my major axes, right? So I have 90, 180, 270. So if I go halfway between, in fact, let me grab a ruler here. If I go halfway between and I draw a line that goes like this, and we would say that this is 45 degrees. So if this is 45 degrees and this is 45 degrees, if I add those up, I get to 90, okay? And if I kept going over here, so we're gonna say that this line right here is 45 degrees. And I have another line, and if this is 45, and I add 45 degrees to this, I know that this is 135. And then 135 and 45, and I can do this going all the way around my unit circle. So I get to 270, I do it again, this gets to 335, and I do it again, and I end up back here at 360. Okay, so if this is what we know that if we start at 0, what we're going to do now is we're going to go to radians. And one of the things that we talked about and that we looked at when we did the unit circle is we said we know pi equals 180 degrees. Okay, so if I look at my unit circle, I'm starting at the same spot. I'm starting at 0. So here's my initial side. I'm starting at 0. And I know that 180 equals pi. So that means this right here is going to be pi. Well, if this is 0 and this is pi, just like up here, 0 and 180, half of 180 is 90. So if I look at this, this would be 1/2 of pi, and we don't write it that way, we just write it as pi over 2. So 1/2 of pi is pi over 2. So I have 0, half of pi, 1 full pi, and then technically down here, what I have is 1.5 pi, but we don't write, we'll never write anything as a mixed number. Everything is going to be an improper fraction. So we say this is 3 pi over 2, 1.5. And if you remember how to convert this, we would say 1 times 2 plus 1. So 2 plus 1 is 3 over 2 pi. Okay, so let me draw my lines back on here so that we can see this, because I think it makes a lot more sense to see it this way. All right, so if we said that up here that 45 is halfway between 0 and 90, we say that this is 45. Well, halfway between 0 and 1/2 pi, so if I want 1/2 of 1/2 pi, this is going to be pi over 4. So this value that I have here is pi over 4. Now, what this is saying is 45 degrees is the same as pi over 4. So if I kept going around my unit circle, I would have pi over 4 plus pi over 4. So I'm going to do this over here. So pi over 4 plus pi over 4. I have the same denominator, so this is 2 pi over 4, which reduces to 1/2. Okay? So then if I was to keep going around this unit circle, if I was to keep going, I would say, okay, this is pi over 4. So now what I have, I'm going to think of this with the common denominator of 4. So this is the same as 2 pi over 4, right? We're not going to write it this way. We're going to write it in the most reduced way. But if I think about this with a common denominator, this would be 2 pi over 4. Well, if I add pi over 4 to 2 pi over 4, I get 3 pi over 4. And then I add another pi over 4, and I get down here to pi. Well, another way to think about this is if I have 3 pi over 4 plus pi over 4, this gives me 4 pi over 4. So here's one of the things that I want you to think about. No matter what that denominator is, no matter what the denominator is as we go around this unit circle, I'm going to show you another one here in a second. This is always that denominator, right? So with the same number on top. So if, for example, I was not using pi over 4 and I'm using pi over 6, that makes this value of pi 6 pi over 6. If I'm using the value of pi over 3, that makes this value of pi 3 pi over 3. Now, this concept right here that you see in pink is going to be really important, and we're going to come back to that here in just a second. So here, again, I'm going to use this concept of 4 pi over 4, and I add another pi over 4, so 4 pi over 4 plus pi over 4, so this gives me 5 pi over 4. And then I add another one, and I already know that this is 3 pi over 2. Well, let's look at this. 5 plus 1 would give me 6 pi over 4, which reduces to 3 pi over 2. Okay, then we have another pi over 4, so 3 pi over 4. Sorry, I want to use my denominator 4. So this would give me 7 pi over 4. I add another pi over 4, and now when I come back around, this gives me 7 pi over 4 plus pi over 4, which is 8 pi over 4. And what does 8 pi over 4 simplify to? 2 pi. So as I go all the way around, this is the same as 2 pi. So if you remember, we said pi equals 180, so 2 pi would be 360 degrees. So as we go halfway around the circle, I have pi. All the way around the circle, I have 2 pi. So I know that this is super messy, and what I don't want you to do is try to memorize these different points. I want you to think about it in terms of fractions. So for example, if I had pi over 6, well, if I was to convert pi over 6, I know that pi over 6 is the same as 30 degrees. You just have to know these, right? If I have pi over 4, this is the same as 45 degrees. If I have pi over 3, this is the same as 60 degrees. So one little cheat that I remember is these, the other one that was important is pi over 2. And we know pi over 2 is going to be half, so this is always going to be 90 degrees. So the way I remember this is if my denominator is 3, I'm always going to end up with a multiple of 60. If my denominator is 6, I'm always going to end up with a multiple of 30. So it's kind of opposite of what you think. It's not 3 and 30, it's 3 and 60, and 6 and 30. And then 4 is always going to give you this multiple of 45. So if I was to, hold on, I don't want to do it right in the middle like that. If I was to look at, for example, this one, pi over 6, this is a 30-degree angle. So if I have a 30-degree angle, it's not going to be as big as my 45. So I'm going to have something that looks like this. And then on this side, I would again have something that looks like that. So if this angle right here is pi over 6, and this angle over here is 6 pi over 6, okay, I start at 0, this is pi over 6, this is 6 pi over 6, that means it's a little bit less than a full one here, so this has to be 5 pi over 6. And it's a little bit more on this side, which is 7 pi over 6. Now, if I go all the way around the circle, I know that this is 2 pi. And when my denominator is 6, it's the same as 12 pi over 6. Well, if I start at 0 and I go up 1, I have 1 pi. But if I'm going to go down 1, I'm going to have 11 pi over 6. and I went down because I went all the way around the circle. Same thing if I'm using an angle of pi over 3. If I'm using this angle of pi over 3, then I know I have a 60-degree angle. So this angle right here would be 60 degrees. So if I go all the way around, this would be 3 pi over 3. Let me do my 60-degree angle on this side too. Okay, so if I have this, one less going this direction would be 2 pi over 3, and in this direction would be 4 pi over 3. I go all the way around my circle, I get to 2 pi. Well, when my denominator is 3, 2 pi is 6 pi over 3 because this gives me 2. What's one less than this? 5 pi over 3. So you notice that I would have 5, 6, 7 over here. This is still going to be 3 pi over 2 because it's my axis. Still pi over 2, 1/2. And then I go one less. So this is a strategy. If this is confusing to you, come and see me and I'll go over this individually with you. All right, so let's flip this guy over and talk about kind of what we just did on this. So what we have is for each radian measure, ask yourself, is the fraction between ... is the fraction between 0 and 1. That's this first quadrant. Okay, so this is 0, not 1, sorry, 1/2. 0 and 1/2. Remember, this is pi, and this is 1/2 of pi, so pi over 2. So is the fraction smaller than 1/2? If the fraction's smaller than 1/2, it's in this first quadrant. If the fraction is between 1/2 and 1, 1/2 and 1, it's in the second quadrant. If your fraction size is between 1 and 3 pi over 2, so 1 and 1.5, so 1.5, remember this is 3 over 2. We're not going to use mixed numbers. Just in this case, it's okay to look at this. Or is it between 1.5 and 2? So I go all the way around, and this becomes 2 pi. So you're going to ask yourself, you're going to look at the size of the fraction, and the size of the fraction is going to tell you what quadrant this is in. Okay? So I look at this first one, 3 pi over 4. Well, 3 pi over 4 is between 1/2 and 1. So 3 pi over 4, so 3/4 is between 1/2 and 1. So that means it has to be in the second quadrant. So if I was going to actually write this angle, I know that a 4 is a multiple of 45, so it's going to be right about in the middle. So this angle right here is 3 pi over 4. Okay, I look at this next one, 7 over 6. Well, 7 over 6 is the same as 1 and 1/6, right? 1 and 1/6. So I know that this is more than 1. So this is 1 right here. So it's more than 1, so it has to be in this quadrant right here. Because it's not more than 1.5. It's between 1 and 1.5. So this is my angle right here, which is 7 pi over 6. Now, let me show you the cheat that I just gave you a minute ago. Okay? So if this denominator is 4, that makes this 4 pi over 4. Well, 4 pi, 3 is a little bit less, so I'm going in this direction, and that's how I know it's here. Here my denominator is 6, so this is the same as 6 pi over 6. So it's a little bit more, so it's going to be in this quadrant right here. Okay? If I look at this next one, 5 over 3, this is the same as 1 and 2/3. Well, 2/3 is more than 1/2, right? So if we look at just this fraction, so this is 1/2, but 2/3 is going to be in this area over here. So what I know is that this is going to be in this quadrant. So this would be 5 pi over 3. Now, let's look at my little cheat here. If this is 3 pi over 3, because this gives me 1 pi, and I keep going all the way around, this would be 6 pi over 3. This is the same as 2 pi. So in this quadrant, down here, if I had this, it would be 4 pi over 3. So I know it can't be in quadrant 3. And if this is 6 pi over 3, remember over here I go 1 less, and 1 less is 5 pi over 3. So I ended up in the correct quadrant. So whether you're looking at this as fraction size, or you're just doing this little cheat by converting that into a common denominator, we need to make sure we end up in the same quadrants. Now, what I'm doing here is I'm just going negative. Remember, the negative sign just tells us the direction. It doesn't tell us anything else. So I'm going this direction. Well, pi over 3 is the same as being between 0 and 1/2. So I know I'm going to go this direction, and this is going to be negative pi over 3. With this, 11 pi over 6, if I was to convert this, I would have 1 and 5/6. So 1 and 5/6 is almost all the way around, right? So almost one full rotation. It's negative, so I'm going to go this direction. So here's what I end up with. So this is negative 11 pi over 6. Now, another way that you can think about this is, what would be my coterminal angle? What would be my angle that would give me a full revolution? And that would be this, pi over 6, right? So I know that it's going to end up in this quadrant. The other way to think about it is if I go all the way around, so this would be 6 pi over 6, that doesn't change, and this would be 12 pi over 6. So if I'm going in the negative direction, I'm going to go 1 less, and that's why this would be negative 11 pi over 6. Okay, last one, 2/3. So 2/3 is not quite 1 pi. So my angle is going to end up in this quadrant. This is negative 2 pi over 3. 2 pi over 3 is bigger than 1/2. It goes between 1/2 and 1. So that's how I know that it's in this quadrant. Okay, so two different strategies. I've shown you both. The purple strategy I have here is converting all of these to fractions. It works every time. You just have to be able to compare. You have to know that 3/4 is bigger than 1/2, or 2/3 is bigger than 1/2. You have to be able to know those fractions. Or converting these to common denominators on the x-axis will also help you. Okay. Now, we talked a little bit on one of these questions a minute ago about coterminal angles, but this says find the radian measure of the coterminal angles up above. And we've done this before, but we did this in degrees, and now we're going to do this in radians. So if I look at number 1, so my answer above is 3 pi over 4. And if I want a coterminal angle, what this is saying, remember, is that if it's positive, I want to go a full revolution all the way around. So I'm going to rotate 360 degrees or 2 pi. So what I have is 3 pi over 4, and I'm going to say plus or minus 2 pi. And when I do this, this is going to be either in the positive, or I can go the opposite direction. So my coterminal angle in the negative direction would be this blue. So as I have this, remember, when you add or subtract fractions, you have to have a common denominator. So I'm going to change this to 3 pi over 4 plus or minus 8 pi over 4. And 8 pi over 4 reduces to 2 pi. So if I add this, I get 11 pi over 4. And if I subtract this, I get negative 5 pi over 4. So these would be my two coterminal angles. Let's do one more. Let's do 7 pi over 6. So if I have 7 pi over 6, I'm going to add or subtract 2 pi. So 7 pi over 6. When I convert this with a common denominator, I have 12 pi over 6. So if I add this, I would have 19 pi over 6. I'm just adding 7 and 12. And if I subtract this, I would have negative 5 pi over 6. So these would be my two coterminal angles. And it's kind of messy with that extra work down there. These would be my two coterminal angles to these two. Okay, so a couple of different strategies. It's really important that you do not convert these to degrees and just start understanding what that position looks like in radians. You will not be able to convert these degrees. You need to just be able to do this. Okay? All right.